Hello, my name is Aaron and I'm a Principal Technical Product Specialist for Zscaler Workload Communications. Today, let's take a quick look at AWS Auto Scale functionality to enhance Zscaler Workload Communications. AWS Auto Scale groups, as the name would imply, is a mechanism that allows administrators to grow or shrink a deployment of virtual machines in the cloud to meet the scale requirements of a business. As more cloud workloads demand more bandwidth, AWS Auto Scaling can automatically invoke additional machines to handle the load. As bandwidth requirements subside, the function can then withdraw or shrink the deployment to save on cost. Zscaler Workload Communications supports this functionality to automatically expand the footprint of Cloud Connector appliances in order to provide additional bandwidth towards the Zero Trust Exchange. In the Zscaler GitHub repository, you can find scripts such as CloudFormation and Terraform that will completely automate the deployment of ASG. Here, we've deployed an autoscale group in AWS. By default, 2 Cloud Connector appliances have been deployed in 2 different availability zones. An additional 2 appliances have been configured in the warm pool. The warm pool allows Cloud Connector appliances to initialize themselves yet remain in a standby state. When needed, they can be called into service much quicker than if the autoscale function had to build fresh appliances. So let's take a look at autoscale groups in action. For the purposes of this demonstration, we've lowered the scale-out threshold to 25%, meaning that the data plane CPU for our appliances must be greater than 25% before ASG will invoke any additional appliances. To test this, we're using iPerf to generate some traffic for us. As seen in the output, iPerf is maintaining 25 streams across our 2 cloud connectors and is maintaining around 1.5 to 2 gigabits of overall throughput. Looking at the CPU statistics, we can see that our CPU is beginning to rise on one of our appliances. And as the CPU crosses 25%, we can see ASG kick into action. Here in the activity window, we can see the 2 warm pool instances getting drafted into production to handle the increased load. After a few moments, these instances become in service and are ready to process traffic. We can verify this from the Instance Management tab, as well as from the EC2 console as well. In the Monitoring tab of AWS, we can immediately see the data plane CPU percentage drop as more Cloud Connector appliances become available to service the influx of traffic. So let's stop the iPerf transmission to simulate what happens when bandwidth requirements subside. After cooling down, the autoscale group automatically begins the scale-in process by returning Cloud Connector appliances to the warm pool, which we can see here. These instances will eventually move to a stop state in order to save cost for the customer. So in a nutshell, AWS Auto Scale groups continue the theme of a highly available and highly scalable architecture for Zscaler Workload Communications by dynamically growing or shrinking the Cloud Connector footprint based on the demands of the business. Thank you for joining me in this video, and I hope you found it useful.